This question comes from the word problem that we have, and it says to balance the following in aqueous solution. Iron 2 ion is mixed with permanganate ion in a low pH medium to produce iron 3 ion and manganese 2+ ion. So that's what we have, and that's what I've written out in terms of its formula. And the first thing we want to do is to write down all the oxidation numbers, assign them. That's being done. And identify the two half reactions, oxidation and reduction. That's also being done. So we see that iron is being oxidized and the manganese is being reduced from 7 to 2. So the oxidizing agent is the manganese in the permanganate ion, and the reducing agent is the iron 2+. Okay, so let's go ahead and balance. We're going to split these up into the two half reactions, and let's start by writing iron on this side. So I have Fe2+ goes to Fe3+. And then for the other half reaction, although we'll do one at a time, I'll just write it out for now, and I have MnO4- goes to Mn2+. I don't have to write the aqueous physical symbols here. While I'm doing this, I'll tack them on at the end in summary. Okay, first step, balance all of the atoms except oxygen and hydrogen. So iron, done. They're balanced. 1, 1. No oxygen, no hydrogen, so now I'm going to balance the charges by using electrons. I have a +2 on this side, and I have a +3 over here. So the answer to the question, how many electrons are needed on which side? I need 1 electron on this side. So that becomes Fe2+ goes to Fe3+ plus 1 electron. So now I need to get the other half reaction to this stage before I can balance the electron transfer and then add the two half reactions back together. So now I'm over here on the manganese side. The manganese are already balanced, 1 and 1. The next step is to balance the oxygen atoms using water. So instead of adding 4O, well, that would be silly because oxygen does not exist in this pot as O. It exists as water. I need 4. The next thing I do is balance my hydrogen using H+. I've just introduced not 4 but 8. So now I have 8H+ that are needed on the left. So we say we are adding the hydrogen as it exists in solution. At this point, and you should be following along with the rules if you don't know them yet, at this point we have to ask, I've just added H+, is this really in acid medium? Yes. And that was how we interpreted the low pH detail in the question. So that's fine, and I can go ahead. So on this side I have a +8 and a -1, so that I have a +7 charge on the left and a +2 charge on this side. So I need 5 electrons on this side in order to balance the charge. So each time I execute a step, I'm rewriting the line with that added feature, basically for the purpose of instructing, but I would also suggest that you do the same, because it allows you to check your work at this stage, to check your work one step at a time, going backwards. If there's a problem, you identify at the end. So if you check your list of rules now, at this point we need to balance the electron transfer. So I know that oxidation is the loss of electrons, and that allows the oxidation number to get more positive or larger. So I can see very clearly that one electron is being lost. But in this circuit, if you like, I can't have a loss of 1 and a gain of 5. So I have to make sure that these are the same. And so before I add these two half reactions back together, I will multiply my oxidation reaction by 5. So I'm going to multiply by 5, and that will be 5 Fe2 plus. And I'm going to add it at the same time. So now I'll go over here and add the left side. Plus 8H plus MnO4 minus goes to back to this side for the products, and that is 5 Fe3 plus 5 electrons plus, now I'm over here, Mn2 plus and 4 H2O. I like to do this part in a different color, so, or maybe with a pencil. You want to do it with a pencil. 5 electrons on both sides will go out, and anything else that's common I don't have. Sometimes you'll find that you have H plus on both sides, or maybe some OH minus on both sides, or some H2O on both sides. So just make sure that you simplify your equation. Okay, so in this last step, before I check, I will now put the states back in. Plus 8H plus, permanganate ion, oxidized iron 3, aqueous, Mn2 plus aqueous, and I'll write my water as liquid. Okay, now I just want to make sure everything in fact is balanced. I have 5 iron on both sides, I have 8H plus, and then 4 2s are 8H over here. 1 manganese, 4 oxygen, and 4 oxygen. That's great. And then my charge, a plus 5 times 2, so plus 10, and an 8 is 18, minus 1 is 16, and on this side, 3 5s are 15. And that's 17. What did I say over here? 10, 18, minus 1 is 17. I don't know what I just said a moment ago, but this is plus 17. And on this side, 15 and 2 is plus 17. So we're great. This is correct. And now we would be ready to use this in a word problem. For example, so many milliliters of a known molarity solution of iron mixed with so many molar strong acid, etc., etc. You know, predict the concentration, final concentration of manganese, 2 plus in solution, what have you. This is where it gets, we can add layers to a problem. So this is where it gets fun, where it gets interesting. Okay, so a little more practice on this balancing, and then we'll go to one of those large problems.